Last night's homework answers. Let's get it out. I didn't do all the questions, but I did a lot of them. And let's check and see how you guys did on that. Let's first take a look at the answers to number 2. Are there any questions about number 2, any of the ones there? Look good? All right, what about number 3? The one I think personally that letter A is pretty straightforward. You just have to remember to get everything on one side, okay? I didn't have time to do letter B, but we do one like that a little later in the homework, so I'm not worried about it. Letter C, however, is very easy, but it trips a lot of kids up. It's actually easier than A, but a lot of kids get tripped up by letter C. So let's make sure that you did letter C the correct way. The first thing that you should notice is that they share a common factor. That's always what you look for first. They share a 2x. So I pull out that 2x, and I'm left with 4x minus 1. So then over here, maybe it's the guy on the left, 2x equals 0. Maybe it's the guy on the right, 4x minus 1 equals 0. Solving, I get x equals 0. Solving, I get x is 1/4. So the answers are 0 and 1/4. Okay? My experience is that a lot of kids will struggle with that in the beginning and try to make more of it than it really is. A lot of kids, when they look at this, they want to set up a double bubble, double packages. Not the way to go. You always pull that common factor out first. And then once you pull that out, you got to remember, God bless, maybe it's the guy on the left, maybe it's the guy on the right. Any questions with that one? Okay, number 5 and number 6. Number 5 is pretty straightforward. It's been, it's been a while since we did one, so I just wanted to give you an answer to it, make sure that you were still ahead in the game on that. And then number 6 is a nice little question because it talks about undefined, which is where we started this unit with. And we said undefined, my ironic sense of British humor, the definition of undefined is that you cannot have 0 in the denominator. So I take my denominator, which in this case is a quadratic, and I set it equal to 0. So here's my denominator, and I set it equal to 0. So x squared minus 10x plus 16 is 0. Factor it, add it, and just do what you got to do. Okay? Any questions on that? Okay. Now let's go to scan 5. And this particular problem. So, as I read through this guy, this is a very confusing problem because when they start talking about the stones around the garden. Karen wants to plant a garden with a decorative stones around it. As soon as you start thinking about this decorative stones, you start thinking about the pathway problem that we did yesterday. And you want to draw a perimeter, if you will, around this rectangular garden. The problem is that if you continue to read, it says she has enough stones to enclose a rectangle with a garden with a perimeter of 68. And she wants the garden to cover 240 square feet. What will the length and width of the garden be? So, in other words, the fact that they're putting stones around this is just fluff. It has nothing to do with the solution to the problem. What matters is 2 things. First off, the area of the garden itself is 240, not with some stones added to the garden. It's just the garden. Second, this stuff about the perimeter being 68. This is tricky until you see it. Then it's not too bad. So like the next time you saw this or the time after, you would get it down pat. If the perimeter of this rectangular garden is 68, then don't these 2 sides have to add up to 34? Right? Because altogether 68, these 2 add up to 34, these 2 add up to 34. So if I let the first side be x, whatever it is, then the second side is going to be 34 minus x. That way, when I add them up, I get 34. Now, let's do it polynomial-wise. What is x plus 34 minus x? It's just 34, isn't it? Because the x and the minus x wipe each other out. Another way to look at it is, let's just say that x was 12. The other side would have to be 22. And that way I could add up to my 34. However you want to look at it. But the key insight here is that whatever I let one side be, x, the other side has to be 34 minus x. 34 because it's half of 68 and we're only dealing with half the sides. So then I come over here and I say length times width is 240. Distributing the x, 34x minus x squared has to equal 240. And now it's just like the first question in the quadratic equations that we solved on the homework. We get it all on one side, minus the 34x plus the x squared. You want the x squared to be positive. Factoring a negative x squared is ugly. Make it positive. So I add it to this side. 240 minus 34x plus x squared, but I like the x squared in front. So I make the x squared in front, keep it positive, keep the 34x negative, keep the 240 positive. I factor x minus 24, x minus 10, and then I get it all on one side. And I come up with 24 and 10. And if you notice, 24 plus 10 is 34, and 34 and 34 would be 68, so my perimeter is 68, and 24 times 10 is 240. And that's the area that they wanted me to get. Okay? Any questions? All right. I would consider the last problem on a scale of 1 to 10 about a 7 in difficulty, maybe an 8. 7, 8-ish. Okay? The algebra is more like a 7. The setting it up is more like an 8, maybe even a 9. All right? So keep working on it and practicing it. And my advice to you is when you go home tonight, that you practice on it again, okay? All right, so let's take a look at this guy here, and we have a do-it to work on. So we'll solve this one, and then we'll work on, hopefully, 2 full others. Length of a rectangle is 5 inches more than twice a number. I wish it would say, and the width is 4 inches less than the same number. Perimeter is 44. That's not what you have. Oh, this is 1A. Why is 1A there? Oh, that shouldn't be. Oh, not good. Maybe I clicked on the wrong one. Let's see what I got here. This says, oh, I see. I did click on the wrong one. Quarter 3, lesson 2. Quarter 3, lesson 7. I don't want that. Quarter 3, lesson 3.
Yeah.
Are we good?
Yep.
All right. Consecutive integers. Another type of problem that we can do with quadratics. And if we remember how to set up consecutive integers, this should not be too big a deal. Oh, project. Find 2 consecutive odd integers whose product is 99. First off, if you never used quadratics, 9 and 11, right? Because 9 times 11 is 99. 99 is a pretty straightforward one. First consecutive odd integer.
Would that be n?
Yes, it would.
Then would the second one be n plus 2?
Beautiful. And now, because it says their product is 99, if I multiply them, I get 99. Okay, n times n plus 2 is 99. I actually think this is pretty easy by comparison to the area ones we've been doing. Distributing the n, I get n squared plus 2n is 99. What do I do next?
I mean, I subtract 99.
Yep, get it all on one side. Good. Minus 99. N squared plus 2n minus 99 is 0. Factor. N plus 11. N minus 9 is 0. Maybe it's the guy on the left. Maybe it's the guy on the right. And now, let's think a little. Do I reject the negative 11?
No,
Why?
because it's a an integer and it's also odd. And,
That's right, it satisfies the context, integers and odd.
and it's also not asking for like a real life situation where that would be positive, like a value of negative.
Well, we call that context, and the context in this case is acceptable. So does that mean that a negative 11 times 9 is positive 99?
Yep.
No,
No, it's negative.
it is. It means there's two sets of answers. Let's go back. Remember we said with a quadratic, whenever I see the exponent squared term, that indicates there are two possible answers. Sometimes there's one answer, sometimes there's no answers, sometimes there's two. We have to evaluate it in context. In this problem, the two answers are actually negative 11 and negative 9, or positive 9 and positive 11. They both work. If I do negative 11 and I add 2, as it says to do there, oh, I get negative 9. And isn't it true that negative 11 times negative 9 is 99? And then over here, 9, and then 9 plus 2 is 11, and 9 times 11 is 99. So there are two possible sets of answers, and we should always suspect that when we have a quadratic. That will be what happens most often. Okay? Yes?
What I did is I put it into my calculator with the y equals thing and divided it by x, and I just looked at all the big choices.
Yeah, well, that basically gives you the factors,
Yeah.
okay? But if I would have just messed with your head a little and made it 2n squared, then you couldn't do that.
Yeah.
All right. Okay. Any other questions? All right, so let's move forward a little bit. For example, Anthony, I think if you tried this way, I think you'd have an issue. Do it. Give you about a minute and a half or so to get this done. And put it up on the board. Wah, wah. Okay. Let's see what we got here. Ready? Says here, Sari, your head's in the game, right? Looks like you're up to no good over there. Larger two integers. One less than twice the small. So the first one, we're going to let be x, and then the larger is one less than twice the smaller. 2x minus 1. The product is 28. So 2x minus 1 times x, I don't care which side you put it on, it's going to get 28. Distribute. 2x squared minus 2x, I'm sorry, minus x is 28. And, let's see, I gotta get it all on one side. So, I'm gonna minus 28, and I get 2x squared minus x minus 28 equals 0. Sorry for that mental hiccup. Are we good?
No.
Okay, what we got?
We can get rid of the 2.
Oh, no, I'm saying, is everybody up to this point?
Oh,
Yeah, we're good, okay. So now, there is no common factor, so I'm gonna go to plan B, and I get x squared minus x minus 56, and that factors to x minus 8, x plus 7. But then, since I multiplied by 2 here, what do I have to remember to do? Divide back in by 2, good. And I get x minus 4, and this one would be 2x plus 7 equals 0. Maybe it's the guy on the left. Maybe, just maybe, it's the guy on the right. Add 4, x equals 4, minus 7. Divide by 2. Now, here's the thing. What is a very important word in this question?
integer.
Integers. Is this guy an integer?
No.
Rejected. So the only integer is 4, and this guy would then be 7. So there's only one pair of integers, namely 4 and 7. Jane, now,
Wait, I forgot what you mentioned.
integers are whole numbers, positive or negative, and 0.
So, but can't we just like move it to the 2, make it 2m minus 7? Yeah, well, I did.
Well,
that.
when you're done finding x, you get negative 7 over 2, regardless of what you want to move where. And then that's not an integer. It's negative 3.5. Anytime you have a half, it's not an integer.
Well, but I thought we would just, move it to the front.
Move it.
Move the 2 to the front, like, instead of doing.
I did.
So you only factor. How long was it?
That's a factor. Then I solve, and when I'm done solving, I get negative 7 over 2. Negative 7 over 2 is not an integer, so it does not fit the context of the problem. Okay? AJ?
Why can't we do -4, -7? You said that those two are the only ones.
Because one has to be one less than twice the smaller. And if negative 7 is not one less than twice negative 4. It's one more than twice negative 4. Spencer?
No.
Anything else? Okay, so my experience with quadratic equations is that kids need to bite off a piece, chew it, digest it, play with it a little bit, and then back off. Do some more work, do stuff they're comfortable with. The next day, bite off a piece, chew it, see what they come up with, and so on. So I don't want to hit you with too much too fast. So if you notice, every day lately that you've come into class, we do like 2 quadratics and that's it. And then we move forward. So for the rest of today, you may begin your homework. Spencer, hit the lights. Work on that. If you want to work with somebody, feel free to work with somebody. The one thing I don't want to do is go too fast at this particular
Two
point.
packets.
What are the packet names in there?
Okay, this is lesson 2.
And the other one is?
Lesson 3.
Don't do lesson 2, you already did it.
Okay.
Yes.
For C, like, we just went over it, but I'm so confused. So after I did the distribute, it's not the double distribute.
Right.
And I did 2x equals 0 and then 3x minus 1 equals 0.
What was 4? Okay, so just tonight's,
Nice.
yeah, the 3x minus 1 equals 0.
A plus C.
So like, state my question the right way?
Hold on one sec, I just want to stop this.
I couldn't even recognize. Oh my god.
All right. Okay, what do you got?
So, this is my work.
Good.
So I was.
Well, no, here's your problem. 4 over 2, 8 over 2 is 4. So you have
Yeah.
to change that.
I haven't done that yet because I stopped midway when I saw what you were doing.
Okay.
But because here I did the wrong one, but here I was confused because you usually tell us to turn it into
You
that.
did, no, I did that too. Well, it's gone now.
But then I saw like you
Then I took
said.
it the next step and I said, well, this has to equal 0.
Oh.
So then I solved it.
Oh, I thought you were still at that point and you were
No.
looking at that.
No, and now I look at this and I say, well, that's not an image.
Yeah, okay, no, I see that now.
Okay, good.
As long as not the
Back by the microwave, there's that folding thing. Gracias.